So at first it looks like this differential equation, we could use an integrating factor because it has the y prime, and we could just divide both sides by x. And then it has the y, but the thing is on the right side it's supposed to be a function of x, and it's not. So we then need to use this little hint that says, hey, maybe you should try this, which at first seems like a strange substitution, but watch what happens. All right, so first of all, right here, it says you need to have y prime. So I first need to take their hint, and I'm going to solve for y. So I've got u is equal to 1 over y, and then I could invert both sides, and the y is equal to 1 over u. And then find y prime, so the derivative of 1 over u is negative 1 over u squared. And then because of the chain rule, take the derivative of the u. So that's what y prime equals. So that's what's going to be substituted right there. And then I can, for this y, substitute it with the 1 over u. All right, here we go. So first of all, it says you've got, and by the way, I'm going to keep the scratch paper on the right side and my actual work on the left side. Okay, so we have x times y prime, and then that gets replaced with the negative 1 over u squared times u prime. And then plus, there's just the y, and y is equal to the 1 over u. And then on the right side, there will be negative x, and then y is squared. So if you square 1 over u, that's going to be 1 over u squared. And I notice that the denominators all have u's. So what I'm going to do is clean this up a little bit by multiplying through by u squared. So multiply through by u squared and then simplify. So on the left side right here, those are going to cancel. So it's going to leave negative x and then u prime. Then it's going to say plus, and this one u will cancel one of those u's. So it still leaves plus a u. And on the far right side, they cancel. So it leaves just a negative x. And now, after we've done that algebra, this one is set up so that we can use an integrating factor. In order to do that, it has to start with just the u prime. So divide by negative x, divide by negative x, and divide by negative x. So now it's just u prime, and then in the middle, I'm going to rewrite it as negative 1 over x times u, and then it equals just a 1. So after making that substitution, it turned out to be a pretty straightforward problem, because now we can make the integrating factor. So this negative 1 over x, we would then need to integrate that. So the integral of negative 1 over x dx. So that equals just negative natural log of x. And then the integrating factor is e raised to that. So it's going to be e raised to a negative natural log of x. And if I can get the natural log and the e next to each other, they'll cancel. And I can do that by transferring this negative 1 up here as an exponent. And now the e and the ln can cancel, so all that's left is x to the negative 1, which I prefer to write as 1 over x. Okay, so that's the integrating factor. So go back to the differential equation when I had it right here, and then multiply both sides by a 1 over x. So I've got u prime minus 1 over x times u equals 1. And now multiply both sides by this 1 over x. So there'll be 1 over x times u prime. And then in the middle, multiply 1 over x and 1 over x. So that's going to be 1 over x squared times u. And on the right side, multiply by 1 over x. 1 times 1 over x is 1 over x. And now that we've done that, this left side came from the product rule. And basically, if you just take this and put it in there without the u prime, that's where the product rule came from. So somebody did the product rule with a 1 over x and a u. And then that equals just 1 over x on the right side. And now we can integrate both sides with respect to x. Integrate with respect to x. On the left side, the integral and the derivative cancel. So all that's left is a 1 over x times u. And on the right side, the integral will be the natural log of x. And now this was our last integral, so it's time to put the plus c. Okay, now the original question only had x's and y's, so I need to replace the u. So the u originally was 1 over y, so here we have 1 over x times 1 over y equals natural log of x plus c. And then I still need to solve for y. So one thing I could do is multiply both sides by x. And that means on the left side, all that's left is 1 over y. On the right side, oh, I should have put parentheses when I multiplied by x. So there would be x, natural log of x, and then if you distribute, there's going to be c times x. And then for the very last step, to solve for y, just invert both sides. So it's going to be y equals 1 over x, and then natural log of x plus c times x. Ta-da!